Today, we're going to talk about something you literally feel every single day, but I bet you almost never think about it. That little buzz in your phone.
So, have you ever actually wondered what's making your phone vibrate? It's not just some simple little motor buzzing away. Nope. It's actually a pretty sophisticated piece of engineering, and it has a really fascinating history. So let's peel back the cover and see what's really going on in there.
Okay, so before we get into the nitty-gritty of how it works, let's talk about why it even matters. I mean, that little buzz, it's like a silent secret language, right? It's this super critical link between you and your whole digital life.
And really, this tech serves two amazing purposes. First, you've got social discretion. You can get that important text in a quiet meeting or at the movies, and nobody else has a clue. But, and this is so important, it's also a vital communication tool. For anyone with sensory impairments, it turns what's basically a flat, silent piece of glass into something you can actually feel and interact with. It's a huge deal for accessibility. So where did this whole idea of a silence alert even come from? Well, funnily enough, it wasn't really born out of convenience. It was invented to solve a very, very loud problem. Okay, picture this. It's the 80s and 90s. The sound of being important, that was the constant, annoying chirp of a pager. I mean, by 1994, there were over 61 million of these things, these beepers, in use. And their constant noise was becoming a massive social headache in restaurants, theaters, you name it. The world was crying out for a quieter way to stay plugged in. And this timeline really shows the journey. But check out that key moment, 1996, the Motorola StarTAC. The first really iconic flip phone. It introduced a feature called VibraCall. And this was absolutely revolutionary. It totally solved that noisy pager problem and basically made vibration a standard feature for every phone that came after. It really set the stage for all the cool haptics we have today.
All right, so let's get to the fun part. What is actually making that buzz happen inside your phone? Well, it all comes down to these tiny little components called actuators. Let's break down the three main types that make our whole tactile world possible.
So first up, we've got the OG, the Eccentric Rotating Mass motor, or ERM for short. The idea here is actually pretty simple. Just imagine a tiny motor spinning a weight that's deliberately off-center. Think of a washing machine on spin cycle that's unbalanced. That's basically it. It's cheap and it works, which is why it was so common for so long. But the vibration is kind of slow and not very precise. It's that classic general buzzy rumble you'd feel in an older phone.
Okay, next up, we have the Linear Resonant Actuator, the LRA, and this is a huge leap forward. Instead of spinning something, this uses a magnet on a spring that gets pushed back and forth in a straight line. Think of it like a tiny little subwoofer. This makes it way faster, much more power efficient, and it creates those really crisp, clean vibrations you feel in most modern flagship phones. It's the difference between a vague rumble and a really distinct tap.
And finally, we get to the really high-end stuff, the piezoelectric actuator. Now, this is basically magic. It uses a special kind of ceramic that physically bends the instant you apply an electrical voltage. There are no moving parts to spin up, so the response is unbelievably fast and precise. This is the tech that allows for the most complex and detailed feedback, like simulating the feel of different textures or super sharp, distinct clicks.
And this chart just lays it all out so perfectly. You can really see the evolution. The mechanics go from a simple spinning weight to a magnetic mass to just ceramic deforming. But the real story here, the mind-blowing part, is that startup time. Look at that. We go from a pretty sluggish 50 to 100 milliseconds for the ERM all the way down to less than 1.5 milliseconds for a piezo. That is practically instant. And that incredible jump in speed and efficiency is exactly what turns a crude buzz into a rich, high-definition feeling.
So how does all this new hardware translate into the rich feedback we actually feel today? Well, the technology didn't just get smaller and faster, it got a whole lot smarter too. That big leap from the old ERM motor to the LRA, which Apple famously branded as their Taptic engine, was a total game changer. Seriously. Haptics went from being just a simple alert to being a core part of how you use your phone. That clean little tap you feel when you press a virtual button, yep, that's the LRA doing its thing, perfectly simulating the feel of a real physical click. And here's the thing, it's not just about the hardware anymore. Super sophisticated software now gives developers a whole toolbox to design custom haptic effects. They can control not just how strong a vibration is, but its sharpness, its texture, the whole shebang.
This lets them create an incredible range of feedback. Everything from a gentle little nudge to confirm a payment to a full-on immersive explosion in a game.
But this amazing technology, it's not just staying inside your phone. Oh no. The haptics market is absolutely exploding, and it's about to change how we interact with the entire digital world around us.
And the numbers here are just staggering. I mean, look at this. The global market for haptic tech is projected to jump from about $14 billion in 2025 to nearly $28 billion by 2032. It's going to double in just 7 years. And that's all because we want more realistic and immersive digital experiences.
So what you should really take away from this is that the very same tech that buzzes in your pocket is expanding into, everywhere. It's making gaming feel more real, it's creating safer car dashboards that let you feel a button without taking your eyes off the road, and it's even powering surgical simulators for doctors. And the most mind-bending application of all? Get this, touchless haptics. They use ultrasonic waves to let you literally feel virtual objects floating in midair. Wild, right? So the next time your phone buzzes, just take a second and remember the incredible journey that's packed into that tiny, silent signal. I mean, it started out by solving a simple problem, a noisy pager, and now it's literally building the foundation of a future where we can touch the digital world. It really makes you wonder, doesn't it? As our digital world becomes something we can not only see and hear, but truly feel, where does the simulation end and where does reality begin?
Don't forget to like and subscribe for more How Meets History.